all that kind of stuff. Okay, so it's not big stuff. Um, but you will have quiz 1, 2, and 3, and the chapter 0 packet will be the midterm grade. Because of the way things work out, your next quiz will be on Tuesday next week. No, Wednesday next week. 4-day weekend. Okay. Wait. Wednesday next week isn't the early release, is it? No. Okay. That's a week after. Whew. Yeah. When we have early release, we'll never do a quiz on those days just because of the time allotted. Um, in fact, some of our early release days, I might just say the hell with it and have FUBAR day. So y'all leave me alone and I grade stuff. I don't know. It depends on how far along we are, whether we're behind or not. Ah, right. So, um, let's get going. Finish off 1.5 and just keep chugging along. Oh, I should make the chapter 2 notes. I should do that today. Okay. So the beginning of 1.5 was going through, there's all these different types of transformations. There's all these different types of functions that we learned throughout Algebra 1 and 2. We shouldn't have to have a lesson on each as to how to graph them, because at the very least, everything can be graphed by dump it in your calculator. Okay, we can always graph by table. That's why it's one of the first things that you learn. However, if you know how to graph by transformation, meaning you know what the parent graph looks like, you know that a square root function has not really a vertex, but like an origination point, and it's perfect square steps on their side. If you know that, then you can just move the graph left, right, up, down, all that business. And that's where 1.5 left off on Thursday. So throw it all together in one shot. You look at all the different types of functions on this page. I see quadratic, cubic, constant, linear, or identity. I see reciprocal, absolute value. Like, you got the whole gamut here. We did a little bit of piecewise before, but that was like, here's a line, here's a line. This is going to be a little bit tougher because we usually graph these by starting at a particular feature, right? The y-intercept, the vertex, the origination point, the inflection point, whatever it may be. And if that's not on my specified domain, it could be tough. So my recommendation, you don't have to do it this way, is you just lightly do the entire graph and then erase the parts that don't matter. Okay? That's my recommendation. Doesn't have to be what you do. So, wake up, Frank. Wake up. 3x squared, what's the parent function? What's the graph look like? Wake up, class. What's the parent function? X squared. What's the graph look like? Parabola. U. Okay. Where's my vertex? Where vertex of this dude? 0, 0. Okay. So I'd start there, and I'm going to do perfect square steps, but 3 times as large. So over 1 up, not 1, 3. Over 2 up, not 4, 12. And then I very lightly, that's why I'm on thin marker, have parabola. I don't want entire parabola. Where do I care about this? Okay, only when x is less than -1. So at -1, do I put an open circle or a closed circle? Okay, so I'm going to put an open circle when x equals -1, and then I'll follow that graph. And everything else can nicely get out of there. Okay, here, you get out of here too. So, move on to the next. You say, what even is that? It's just a number. Okay, so don't be pedantic. If I just see number, kids will get confused with this for some reason because there's not a y equals right next to it, but y'all remember the easiest graphs in the world, vertical and horizontal lines. That says at -1, I have line. But I only care about line when, what? Do your open and close circles. Close circle at -1, follow line until 4, open circle. Everything else, get out of here. And then cubic. Remember, cubics can look like this or like this. It depends on what kind of junk is in the middle between your cube term and your constant term. If it's in transformation form, though, it always looks like this. So I'm going to take my point of inflection in the middle, which is transformations. Remember, it's bass-ackwards land. If it says -5, I really go this way. If it says +5, I really go that way. And +2 is outside the grouping, so regular up 2. So I'm going to head right 5 up 2. 1, 2, 3, 4, 5, up 1, 2. And then follow cube steps. Over 1, up 1. Over 2, up 8. Left 1, down 1. Left 2, down 8. Yeah. And I would make my whole cubic, but I'm not going to follow that entire thing. I'm only going to follow it when greater than or equal to 4. So I go to where x equals 4, I put closed circle, and I follow cubic. Go and get rid of everything else. That's your final product. Okay. Now when I say do the whole thing and then erase, you know it works for some of us. If you don't need to, don't. It's overkill. But if you need to because you're having trouble with how far out in each direction I go, then very lightly do each graph and then come back over it and erase the parts that don't matter. Okay? So this assumes that you know how to graph all this stuff from algebra 1 and 2. Get them. In these two problems, you have 6 different types of functions. Let's see what you got. Was that Angry Birds? I didn't think anyone still played that. I've been seeing a resurgence in Clash of Clans too. More kids doing that. Okay, so graph the line. Erase everything but here. Graph the cubic. Erase everything but here. Graph the reciprocal. Erase everything but here. Oh, that's weird. Got everyone else today, right? Yeah, I think so. PreCalc. And around the room, everyone starts checking their phones. Yes, putting the grades in is that fast. It's the actual grading that takes forever. Okay. So, y'all should have quiz 1, 2, and chapter 0 packet are in. Um, quiz 3 will be in later this week. I'm hoping to get those handful that were gone on Friday, get them in soon. If you ever need to make up a quiz, I've got spaces available up at the front here during Spartan time. I hate to break it to you, I got freshmen. Okay, I've got 23 freshmen in here. Most of them are good. They just hang out in the back and do their thing. But I have 3 of the 4 kids in the freshman class who have 5 or more Fs. Yeah, they're impressive. Um, so I got a couple of knuckleheads in here. Right? They actively They will just sit here and stare at the wall for 90 minutes every other day. Just refuse to do anything. But anyway, if you need to come make up a test, you can always come down during Spartan time. It is relatively quiet in here. Otherwise, I'm here every day at about 7:30. So come in early, knock it out. Most of these take about a half hour, right? Or that's what it's been. As long as you have the review done beforehand. My prep is White 2. I know a few of you are already wandered down here during that time anyway. And there's always after school, Tuesdays and Thursdays, I have game club in here after school. But if that's the only day that works for you, usually Dad gets pretty good with me sending a kid down there to do it. So if that's the only day that works for you, we can do that too. If you need to make up a test, come make it up. Yeah, I'm really flexible on that. The biggest thing is that you talk to me and have a plan. Okay, if someone just doesn't do anything or doesn't show me anything for 2 weeks plus, I gotta assume you're just not gonna do it. And I put in the missing. But if you talk to me and we got a plan, that's a different story. Usually what I do is leave stuff blank until you come and do stuff, because y'all know what it's like to be gone for 2 days because you were sick. You come back and you've got like 9 zeros and missings in the grade book because the teacher just said, screw you, you weren't here. Okay, I don't think that's fair. I leave it blank. It doesn't count for you or against you. Okay, because it's math, it's scaffolds. I know you're going to do it eventually, or else you're screwed. Okay, so there, grades, test stuff, all that out of the way. Round one. I got a line. Line starts at -5, slope is 1. Okay, it's about there. Cubic starts at 0, 0. Cube steps of 1, 1, 2, 8. -1, -1, -2, -8. Kind of like that. And 2 over x is a reciprocal function that looks like 2 divided by 1, and 2 divided by 2 is going to be at the points 1, 2, and 2, 1. It kind of makes little L shapes, like if you play chess. Yeah, it's the knight. Okay, so we're going to be about there and there. Now, I'm not going to leave all this on here. That's messy. Instead, we just have that on here so we can see this is where all the graphs would have been. Also, if you dumped all 3 of them into your calculator, this is what it would show. I only care about the line from 0 backwards. I only care about the cubic from 0, open circle, to 2. That was off. Here. And I only care about the reciprocal after 2. So open circle onward. Everything else, get out of here. Okay, everything else gets out of here. How'd you do? I don't need to put the asymptote on there because it wasn't part of my domain where I cared about it. Now, when I was initially starting the graph, I would have done lightly my crosshairs for those vertical and horizontal asymptotes, yeah. Okay, round 2. It's a quadratic that moves left 6. So I go left 6. Perfect square steps, 1, 1, 2, 4, 3, 9. Mirror across an axis of symmetry. Likey so. A orange. There we go. Y equals 7 is just womp. And see who actually watched the video. That isn't in normal transformation form. Remember, y equals a times the function of b separated from x minus h plus k. It's not in the correct form yet. It's always x minus h, right? So negative x plus 4. It's still not in the right form. B is not separated from x minus h. And that's why some of us might have been caught off guard. This doesn't go left 4. If I factor that negative out, so it's in the B position, separated from x minus h, I see, oh wait, I'm going right 4. Now, if that caught you off guard, or if you plugged it in your calculator to double check what this looks like, you might have been confused. Why is my V over here? And it's because if I put it in the correct order and factor out the B, so I have B separated from x minus h. Okay, now the two transformations are horizontal translation, right 4. What's a negative in the B spot do? A horizontal reflection. What's a horizontal reflection of an absolute value look like? Exact same thing. So it doesn't affect the graph, okay? But sneaky, sneaky. So we got this guy and this guy. Make sure we got all the colors there. And then I'm going to come back and do it for real and say I only care about the parabola less than negative 5. So go to negative 5, open circle, right there. I only care about this from 5 to 2 inclusive. So here to here. And I only care about this after 2. So I'm going to open circle that guy, then get rid of everything else. Bonus round! Since I saw a couple of us make some mistakes with this on our quizzes. Find the domain and range of this. The look on Kate's face. The domain is all real numbers, yes. What about the range? 0 to infinity. Okay. Just because you got open and closed circles in there, just because it's piecewise, doesn't mean that it has to be broken up into really stupid sections of unions. All right. We're getting better. Okay. Quite fortuitous given the sports ball event that some of you may have watched. I don't. I stopped caring a long time ago. So this particular problem, I like it because it comes at a quadratic from a couple of different angles, and I want to show you that there's different ways to approach it. But 2, it also presumes a lot of specific knowledge on a person's part. Yo, how long is a football field? 100 yards. No. 120. Why is it 120? Because each end zone is 10 yards. Okay, it's one of those random things that if you don't sports ball, then you wouldn't know that. Okay, so path of a 60-yard punt can be modeled by this particular equation. G of x is vertical distance in yards, so how high, and x is horizontal distance. So when in doubt, draw it out. Green. There's my foosball field. There's my end zones. Here's midfield. And then we break that into 50 yards each section, so 4 sections apiece. 1, 2, 3, 4. 1, 2, 3, 4. Okay. So why are we having a panic attack? No, they're not. See, because I could stand up here and try to make them like that, but it's not going to work. So I'm just going to roll with it. We call these stick figure Steve sketches. See? There's Steve. Ironically, I can actually draw when I give a damn. So, I have equation, and it says x equals 0 corresponds to the kicking team's. Okay, do you know how the game works? The kicking team's 20-yard line. What is that? No. Dude, don't you play football? Yes. If they're kicking that way, then this side is the kicking team's side of the field. Yeah. Okay. I didn't hear what you said. Oh, okay. All right. So here, let's do this so we understand. This is end zone. End zone. There we go. Okay. So it says x equals 0 corresponds to the kicking team's 20-yard line. So here's end zone. Here's, I'm a kick from here. Function g of x is going to show my vertical distance compared to horizontal distance. Okay? Describe the transformations used to graph that. How do I do transformations of a quadratic if it's not in quadratic or not in transformation form? We tried showing you in Algebra 1. You didn't get it. We showed you again in Algebra 2. You kind of got it for a second and then you forgot it. You can complete the square on a quadratic, keeping everything to one side. I know you don't like it, you can still do it. G of x is negative 1/15 x squared plus 4x plus 1. Stage 1. I say, to complete the square, I need a perfect number here, so this is a perfect square trinomial. So normally we would say variables on the left, constants on the right, divide everything by a. But since I want g of x to stay over here by itself, that changes to group your x stuff shove him out of there, right? Make room for where is the perfect square number going to go. Then instead of dividing everything by a, because you'd end up having to divide over here as well, and we want to leave g of x alone, but I still don't want that negative 1/15 in front of x squared. What can I do instead of dividing everything by it? Well, in this case, dividing by a fraction is multiplying by reciprocal. I've got parentheses there. Factor it out. I'm only going to divide these two terms by a negative 1/15 because I'm factoring it and leaving it outside of those parentheses. So a negative 1/15 out here. If I take this divided by negative 1/15, I just get x squared. We just said dividing by fractions, easy as pie. Flip second multiply. If I divide 4 by a negative 1/15, I'm really multiplying by a negative 15. Negative 60x. Still got that 1 hanging out there. Okay, now complete the square. What is the magic number I always add to complete the square? It's always the same thing. b over 2 squared. So right now, what is b?
Negative 60.
Half of that.
Negative 30.
Squared. 9 hondo. And this is why most of us just kind of yeeted that out of our head in Algebra 2 is, did I really add 900? Look at the parentheses it's inside. I didn't really add 900 because there's a negative 1/15 on those parentheses. So what's negative 1/15 of 900? Everyone, I can smell the burnt wiring with everyone here trying to mental math that. Y'all just use a calculator. It's okay. It is 60, yes. Negative 60. So since putting 900 here really subtracted 60, if I subtract 60 on this side, I'd subtract 60 on this side. I don't want to do that. So I will add 60 to balance it out. Getting, blue. G of x is negative 1/15. It's always half of b, x minus 30, the quantity squared plus 61. This is the part that makes kids mad. That 30 and 61, what is that? If I'm in transformation form on a parabola, that's a vertex. Could you have found the vertex of this any other way?
No.
Negative b over 2a, plug it in, dump it in my calculator, put Blinky on both sides. That's why when we showed you this in Algebra 1 and 2, kids just said, screw it, I'll do the negative b over 2a thing. Okay? You can do this. I'm bringing it up because this is a skill we need for our conic sections later in Chapter 7. Okay? Now that I have it in this form, yes, you could have just negative b, so negative 4 over 2a, so over negative 2/15. Plug it in, you get 30. Put 30 in here, you get 61. Yeah, you could have done all that, and the a value is always the same, whether in standard form or general form. Now tell me the transformations. Okay, so part A is going to go down here. There's 4 transformations there to the parent graph of x squared. What are they? 4 of them. Reflection over x-axis or vertical reflection, depends when you say it. So I have a vertical reflection. What else? Vertical compression by 1/15. I know it's a compression because it's less than 1. That minus 30 grouped in with the x in Bass-Ackwards land.
Transformation of x.
Horizontal translation
30.
30 that way. And a vertical translation up 61. So what that means in the context of this problem is they kicked from right here That's 30 yards in from the end of the field. You'd say, but they're at the 20-yard line. This is where you have to know there's 10 yards for the end zone. Okay. That you can tell the publishers of this particular textbook, they assumed a lot. Okay. So I'm 30 yards in from the end of the end zone. They kicked it, and because it has a vertical translation up 61, that means the vertex of this thing, oh, I'm sorry, it happens to be 30 yards in from there. The vertex of this thing is going to be 30 yards away from, so at 50 yards. 61 yards in the air. I mean, think about that. Think about ballpark, how long 60 yards is. Think about half a football field. They kicked it that high in the air.
183 feet in the air.
Like, that dude better wave or else he's getting clobbered. So, suppose the punt was from the kicking team's 30-yard line. Rewrite this to reflect the change. So this equation is they kicked from 20-yard line. They said, now you're going to go kick from the 30-yard line. What did they do? They went 10 more yards to the right. So if I go 10 more to the right, what type of transformation is that? Horizontal translation to the right, bass-backwards land. I just go another 10 that way. And that is the only change. This is just an application of transformations. Transformations can be applied to any graph where I understand my independent and dependent variables. This is a very specific example. Y'all, I could have done this with, I don't know, someone threw a rock in the air and how long do I have until it comes down and hits my brother in the head? Like, it could have been lawn darts. Hopefully your generation has never played with lawn darts. That's how people got impaled. I could do this with the input is time and the output is the number of screaming weasels. I don't know. Like, you could have any context where you have an input and output and then you attach a transformation to it and tell me what do those mean. Because the transformations tell me I'm moving those variables up, down, left, and right. This one is very small. This one, you don't have to do any of that complete the square business on it. It's like you could probably do the problem in 30 seconds. Okay? Try it. You do have to read the problem, though, to see what number goes where and how is that affecting things. Okay, you all remember back to your physical science dealing with electronics, resistance in a circuit? You know, if anyone took the DC electronics class last year with Banton, I don't think they have it this year with Daggett. Probably next year. Comes back to that. Always comes back to that. That's a thing that should have been just beat into your skull all throughout Algebra 2. Those four things, A, B, H, and K, they all do stuff. Okay, this one. Current flowing through a DVD player described by I of X is square root of X over 11. X is power in watts, 11 is resistance in ohms. That's going to be relevant later. Describe the transformations. Right now, it doesn't look like transformation form. It's close. It's simplified. But I need to separate B from X minus H. And it's as simple as pulling that 1/11th out from X. Like this. So I got a 1/11th in the B spot. Do you remember what B does? Horizontal stretch and compression, but because I'm in bass-ackwards land, who actually did the video? It is a horizontal stretch by 11. It's in bass-ackwards land. B, see, normally with A, you have, if the absolute value of A is less than 1, then it's going to be a stretch. If the absolute value of A is greater than 1, you have a vertical compression. Oh, wait, I did those backwards. Sorry. With B, think about input. You're saving money for a car. So the input into my bank account is X. What happens to your goal when I take that input times 1/11th? You're saving money for a car, and I'm going to take whatever money you're saving times 1/11th. Doesn't your goal get 11 times further away? Okay, so if you mess with the input, that's why we call it bass-ackwards land. It's always going to have a opposite effect on whatever your goal is. Say you are saving up money, you want to buy a new phone. Your parents say, too bad, you got to buy it. I've gotten you like 4 new phones because you can't take care of them. You got to buy the next one. It's going to cost you like $800 out of pocket. You're saving up money. I'm putting $200 into my savings every month, working hard for the money at McDonald's, and it's going to take me 4 months to get where I'm going. What happens when your birthday comes along and grandpa gives you $100? Input plus 100. What happens to your goal? Doesn't it get closer by 100? That it has an opposite effect. When you mess with the input, it has an opposite effect. So when I take 1/11th times this, it's going to have a horizontal stretch by 11. It's always by the reciprocal of B. It has a reciprocal effect, opposite effect. Okay. The resistance of the lamp switches over to 15 ohms. What changes about the function? Okay. Said you just have to be able to read. So I of x is now square root of x over 15. So tell me, does that make my goal go further away or come closer compared to the other graph? Right? Because now I have a horizontal stretch by 15 instead of a horizontal stretch by 11. It says to graph them both on the same screen just so you can see them. It just means you're going to have one looks like this and the other looks like this. It's just stretched a little bit more, and that's it. Okay, a little bit of cross-curricular stuff here. Do you remember the difference between resistance and current? Current is in amps. What is current? Come on, y'all took physical science. What's current? Flashbacks, seeing like napalm and choppers in the background. Okay. Still, but yes. Here's the deal. Current is, think about the current going through a garden hose. When I say the current in an electrical circuit, I'm saying how much electricity is going through that wire. Okay, it's not the voltage that kills you. You can get hit with 100,000 volts if you want, if it's slow enough. Okay, if it's slow enough. Okay, I want you to think about who's small with an O. And okay, everyone's looking at Lori. Okay, so I want you to think about the difference in impact if, okay, Riley's got like tree trunks. Dude works out, right? I want you to just walk at someone like this. Clearly, like he's a bigger dude. He's got more force to him. But if you just walk at someone versus Lori comes running from across the room at someone, which one's going to have a bigger impact, right? And now I can kind of see just Lori like leaping spear someone from across the room, okay? Even though there's less mass there, well, you know what? The force that it was being rammed through, that's current, okay? Think about the shower head when someone flushes the toilet or not, okay? Right? How much force is coming through it? That's current. And it's the current that gets you. Okay? Which you will know if you've ever survived a electrical shock from a 220 line. Transformations with absolute value. Y'all didn't get this enough. Well, I don't think the new curriculum does transformations with absolute value. Anyone ever seen this before? Maybe, could be, chance of. Okay. First one. If I absolute value a function, see how the absolute value brackets are around the entire thing? What do I get from the entire function? X or Y? Input or output? Output, the entire thing, right? So this says I absolute value my outputs, my Y's. Well, look at the graph and then think, what does absolute value mean?
Not be negative.
Okay, distance from 0 can't be negative. So this says Y's can't be negative. So I take all this stuff that was down here and I reflect it up here. And then everything else goes away. That's an absolute value reflection. The Y's can't be negative because I absolute valued the whole thing. Okay? So whatever y values existed below the x-axis, you reflect them back up above the x-axis. Okay? Toxic positivity in math. You're not allowed to be negative. Get up here. Okay? Versus if I if I absolute value the x. Okay, now if I do absolute value of, is x input or output?
Input.
So if I put in a -3, it's never going to tell me what would have happened at -3. It's going to tell me what happens at 3. So this is like revisionist history. This says if I put in a -2 and it should have had this, it's going to say, nah, that didn't happen. This happened. Because when I absolute value my input, I never see the negative. I never see what happened with a -x because it's going to tell me the positive x version instead. What it does is takes everything over here and it overwrites the stuff over here. And this, they say it never existed. Don't worry, you're not on stolen land. Okay? That's what an absolute value does. Is it absolute values this, saying anything that I would put in as negative is going to come out as the positive variation instead. Okay? So next to this, I would like you to write the positive x's overwrite the negative x's. They overwrite it. The stuff on the left-hand side of the graph just doesn't exist. So this graph over here, we're just going to sketch it. It's okay. Wide. There we go. So the first one says I absolute value the entire function. Take a look at this guy. All the y's become positive. So this is still here, but now this part doesn't exist. This part doesn't exist. They come up here, like that. Really? Ungroup those? That was terrible. All right, here. Since apparently we're cross-eyed enough, we're going to just steal this graph. Okay, I'm going to take this, and since this goes back to like negative 2.4-ish, down 4, I'll just put that arrow up here instead. Since this goes down to about 1, -3, I'll go over to about 1, +3. Like this. We have the regular graph. All of that stuff disappears. There's my graph. Looks like Aunt Judy fell over. Okay. So everything that was negative down here in y's just gets reflected upwards. If I absolute value the inputs, then what? So if I say -1, -2, it says, nah, +1. Positive 2. So even though I'm pressing the -1 button, it's giving me the +1 answer. It is overwriting things. So everything that was over here, they're going to say, when I go to -1, I ain't telling you this. I'm telling you what happened at +1. When I go to -2, I'm not telling you what happened at -2. I'm telling you what happened at +2. So everything that was on the left-hand side gets overwritten. By the right-hand side. Okay? You press -3, it doesn't tell you -3, it tells you +3. Okay? Boy, could we go off on a tangent with that. It's just about which part of the graph are you going to reflect over. That's it. Now, I know there's only 2 graphs down here. So instead of having you do both, I'm going to say for this one, do absolute value f of x. And for this one, do f of absolute value of x. That way you're still doing one of each, but otherwise that would be just kind of a cluster of a graph. Okay, so only do one each. Don't overkill. But how do I reflect things? Do I reflect them and they overwrite? Or do I just move them upstairs? Now I know that part stays there for sure. What do I do? Okay, flip what? Which part where? Right to left or down to up? Okay, everything that was a -y value is just going to get flopped up here. So if this was down at approximately 1, -5, then I'm going to go to +1, +5. If this was at about 0, -1 and change, I'm going to go to +1 and change. If this was at -4, about a third, I'm going to go to -4, +a third. Like that. Okay. Now what's really fun is if I had done instead absolute value of x instead of the entire function, I'd get this. This would then go straight down, and I'd have to mirror this one over instead. If it was absolute value of just x. Like that. I'm just showing you both, okay? But do you see how you'd get kind of almost like a wishbone at the bottom? Because it would reflect over and overwrite it. And I didn't want all of that on the same graph because it'd be kind of messy. This guy, if I absolute value just x, everything that is on the right-hand side gets reflected to overwrite the left-hand side. So you got to be careful about how you draw all of your circles here. This was open circle to close circle. So what's that at? 1? Yeah, okay. Dot, circle, dot, circle, dot, circle, dot, circle, dot. So if I reflect those, that means I still have open circle over to dot. Open circle over to dot. The closed circles are always the furthest part away because I'm reflecting it. And if you had gotten here, you would have been oh so close to the answer. There's one tiny point about this missing.
This isn't the correct one.
Right? Literally a circle in the middle because look at this guy. If I reflected over the y-axis, what does your face look like when it's smashed up against the mirror? Smash. It's right there on the line of reflection. It's kind of like, what is the opposite of 0? 0? A negative 0 is still 0, right? So please include that little dot at the top of the pyramid there. Otherwise, you'd be missing just a hair of the answer. Okay. How are we doing with the graphs? The piecewise ones. I don't care if you like it. I'm asking if you can do it.
I can do it. Most of the time.
I'm seeing some hesitation around. Come on. Emperor thumbs. It's like, yeah, I'm good. Yeah, a little fuzzy. I should probably use another example. Dude, I'm so lost. Okay. Yeah, that's what I thought. I see some hesitation in the room. Let's do number 5. I want to do one more. One more of the piecewise, and then we'll move on to compositions and stuff. Or operations. We probably won't get to compositions today. And I can pretty much guarantee you're going to have a piecewise function like this on your next quiz because it's a really good way to test multiple items of transformational knowledge. Yep, there is a step function on here.
Shut up. Respect.
Sort of that back corner is like a rerun of Beavis and Butthead. Said your hair looks nice.
No. I'm just kidding. Shut up. Don't. I have my pencils. I have. Wire. With a stick. With a stick. Carry a big stick.
You need to do option A before you can get to B. Um, that's all three graphs, but I don't care about all of that in every one of those instances. So I only care about blue line when. Okay, so I go to x is -3, close circle, go that way. Get rid of the rest. I'm going to go to green line. I only care about green line when? -2 all the way to +2. There's a gap in it. How dare they? Okay. Yeah, they got me. Okay. From there to there. And then don't care about the rest. Bye-bye. Yep, there is a gap in the domain. Oh, there's two gaps in the domain. And then from 4 to 6 means I don't care about this. Oh, you're going to do the whole thing, aren't you? God, I hate you. Okay, from 4 to 6. So there's 1, 2, 3, 3 to 4. Okay, what you got to be careful about is there's just going to be a dot at 4, and then you'll start the next one. 4 to 5, 5 to 6.
No.
That's a closed.
They're talking about
When I'm at 4 itself.
it's an that was an open circle if you kept going. So if you included 6, it doesn't count.
Are we since like that's what we're starting with switch to?
No, I start when x is 4, and when x is 4, I'm supposed to be at the end of this guy right here. So isn't there a one right there between 3 and 4? Because at 3.7, the greatest integer I've ever seen is 3. Oh, do I have all those backwards? Yup. Yeah. Okay, the dot's just on the other end. There. Yeah. Where's black?
There's still the dot.
Yeah, because you have the open one.
Yeah.
You still have
1, 2. You have the open one below it, right?
Yeah,
And that's
Yeah.
4.
that's 5.999999.
So at 5.99999,
Right, but I'm saying there should be one more open one. Below 4.
No, that's an open
It-
circle.
open circle, it doesn't exist there.
But when you still have it,
This would be redundant because it says there's nothing here.
It can't-
I mean, technically, if you want, I can put it there and 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 there. I mean, you're right, it is there, but that's like saying 1x to the first over 1. Like, yes, there are all those open circles, but overkill. Oof. 2 for 1. Yeah, well, it was a weekend.
I could do like 2 in 50 seconds.
Yeah. Whatever Mama Bear got on Thursday, I got. We don't know if it's like actual alchemical or if it was food poisoning, but Horked my guts out and then just was a puddle on the floor for 24 hours. Go figure. So, I don't know what it was. That's why I was gone on Thursday, is she just couldn't move. All right, come on. 1-6. 1-6 is operations. The first part of this should be the part that everyone's like, oh dear God, thank you. Because it's just operations on algebra. It's like distribute and combine like terms. Back when math was straightforward, right? If they say F plus G, they just mean take the F rule plus the G rule. If they say F divided by G, it's just take the F rule divided by the G rule. And that's it. What you do have to be careful about with these is domain. What are our 3 commandments of domain that we know right now? Thou shalt not divide by 0. So if you ever get an x on denominator, you better state x cannot equal these things. What else? Even root of negative numbers. So if I ever have an even radical, you have to state x has to be from here to here. And log of non-positives. So even 0 isn't allowed in logs. And that one might be a little bit sketchier because I know most of you are coming out of last semester's Algebra 2, and we had to fill a lot of gaps. I know my class was about 5 weeks behind where we normally were. We had to fill a lot of Algebra 1 gaps, but also we just kind of got nailed at the end of the semester with Snowmageddon, and we missed a week of school, and so the log thing might not be as relevant to us right now. Don't worry about it. Our chapter 3, we cover the same stuff. Okay? We just crank it up a little bit. So if you can do basic algebra, this stuff should be fine. When they say f plus g of x, we'll get all pretty colored on here. F is the f rule. When I say plus g of x, I literally mean plus the G rule, and the G rule is this stuff. So I just take x squared plus 4x plus square root of x plus 2. And contrary to some of your quiz 2s, no, you cannot put that x squared and 4x inside that radical. Yeah, some of you tried that. I had some kids doing stuff like, I don't know, say it was like 9x minus 27 plus 9. I had kids writing that as this. That's freshman math right there. Okay. So be careful. All 3 of these are not like terms. So my answer is just that. It's just done. X squared plus 4x plus square root of x plus 2. The directions. Says find each function and state the domain or state the restrictions to the domain. Those are different things. If it says state the restrictions to the domain, then we could pull an algebra 2, and right next to it I would just say x is greater than or equal to negative 2, because second commandment domain. If it said state the restrictions, you can get away with that. But if it says state the domain, you have to use set builder or interval notation. Okay? So this says and its domain. So I will actually write from negative 2 to infinity. When they say f minus h, I've got f, which is x squared plus 4x, h, which is, get back over here, 3x minus 5, minus this rule minus this rule. And how many of us are going to accidentally forget and say minus 5 at the end of this? Okay. X squared, that's 4x minus 3x minus a negative 5. So if you need to put your invisible negative 1 there and distribute, please do so. Nothing wrong with just writing an extra line to show your distribution so you don't screw up your signs. And then this guy doesn't have any of my x on denominator, even radical, or logarithm with it, so I'm going to say my domain is all real numbers. And I was happy to see a good number of us remembered that on our tests, where you can just use that in place of the full set builder notation, because that is the symbol for the set. Okay, if I can add and subtract them, then I can multiply and divide them. Same thing. F times H. F is still this stuff. So I'm going to have x squared plus 4x. And what's that? H over F. So F is going to be down here. X squared plus 4x. G is this stuff. Oh, wait, we're not even using G. Okay. Just going to use H. H. And H. And H is 3x minus 5. And H is 3x minus 5 times. There we go. Pretty colors. I don't know about you, but that kind of helps me to differentiate where things go. This thing goes here, pretty color. Colors match. Otherwise, you ever get in a really involved problem on your paper, and by the end of it, it's just chicken scratch? Just looks like a pencil vomited on your paper, and there's a bunch of letters and numbers in there. So I do it like this so we can actually see where everything's coming from. It says find each function and its domain. When you disturb it, make sure that you do so not like freshmen. I've got 3x to the third minus 5x squared plus 12x squared minus 20x. Okay, make sure you hit all of your terms. If you're going to box method, spaghetti monster, stack them old school multiplication, whatever your jam is. Okay, but my answer, 3x to the third plus 7x squared minus 20x. What's my restrictions? I don't see an x on denominator. I don't see an even radical. I don't see a logarithm. So, everybody allowed to that party. Okay. Be careful here. Because what if that was
X could not equal 0.
okay, we're going to take care of that, but x can't equal 0 or negative 4. We'll take care of our domain. All I did was change negative 5 to a positive 12, and now my answer is going to be way different. Why? Factor. Whenever you see a rational function, factor, factor, friggin' factor. Okay. This, I can't do anything with it. Like if I take a 3 out, I get an x minus a 5/3. Doesn't really do anything for me. If I take out an x, I have an x plus 4. There's nothing they have in common. But this guy, if I were to take out a 3, now they have an x plus 4 in common. Okay? So just watch out for that. Whenever you see a rational function, you have to factor to see if something can disappear. Okay? So in this case, yeah, that's just the answer. That's just my answer. It's done. Now, if I take that x squared plus 4x equal to 0, x can't equal 0 or negative 4. You can either write this in set builder or interval notation. If I think about that number line from negative infinity to infinity, negative 4 and 0, if I just want to get rid of those two, you put that union parenthesis butt crack on there. Say negative infinity to negative 4, can't touch it. Negative 4 to 0, can't touch it. And 0 to infinity. Okay? Everywhere that I want to exclude, you put a union parenthesis on top of it. Most of the textbooks that you're going to see are going to use interval notation. Below that says find them all. Now, for those who have already decided we're done, I hope that you are all the way through these with every bit of it done. Add, subtract, multiply, and divide for A and B.
Add, subtract, multiply, and divide.
Uh-huh.
Oh my gosh. Shut up. What? Huh?
The question is, do you know the domain? Okay. Add and subtract them are really easy. It's just combining like terms.
So, can you write it like x minus 4 plus 9 minus x squared 2? Or?
Yes. Anyone got a guess why I put the radical in the middle on the first two? Louder. Y'all remember standard or general form, where it's always the big dog down to the small ones, kind of like the different popcorn sizes at the movie theater? Okay. You always put like cubed, then squared, then to the first, then 0. Well, x to the 1/2 is in between 1 and 0. Okay. We'll pick it up with this tomorrow.